Hello, my name is Eric Ho,
My name is Hamlet Perkis.
I'm Victor Mendoza.
and we did a Bluetooth tire pressure sensor for Dr. Mohamed El-Hadedy. So our senior project was designing a product that would allow for tire pressure sensing being sent over a Bluetooth channel. So who initially did we have the project in mind for? Initially, we had the project in mind for third world countries where vehicles may be older and do not have the current technology. This was initially planned on being a modernization of a older vehicle. Another area that we identified that could possibly be used, this product could possibly be used, is within auto dealerships where rapid checks before vehicle delivery need to be made. So if you are preparing a vehicle for delivery to a client, you could sit there and very quickly attach this to a vehicle valve stem on a tire and pull the tire pressure and also know whether or not you need to add air or bleed air out of the tire. What does the product do? The product maps tire pressure or maps a voltage and displays a tire pressure on a Bluetooth over a Bluetooth channel through a Android phone. And in the future, we anticipate adding a inertial measurement unit and also getting a readout from the onboard diagnostics from the vehicle to data log. So that way you have a black box feature in a vehicle that may not have necessarily had it on its initial design. So for our product design, we received the requirements from our client, which is our senior project advisor. And from what he told us initially, he wanted a Bluetooth tire pressure monitoring system. So we performed a trade study to find the best suited off-the-shelf components based off of our price and familiarity. And we performed the trade study to help identify those products. After performing the trade study, we identified that we wanted to use a Arduino along with the Bluetooth module as the processor and transmitter. From there, we searched high and low for various different pressure transducers, and our initial choice was discontinued. However, we found a suitable alternative after a little bit of communication with our supplier. And after that, we purchased various fittings and attachments so we could obtain the pressure from the vehicle valve stem and apply that pressure to the sensor. After we managed to do that, we needed to code the application that we need to use on our Android phones. And initially we thought we could do that with Kotlin, but due to time constraints, we switched over to MIT's App Inventor, and that allowed us to get a working product out rather quickly.
There are many different pressure transducers. For instance, there's a temperature, pressure, displacement, oscillator, flow, and inductive. Since we're working with air, we decided to use a pressure transducer. Many of the fittings that pressure transducers come in were discontinued, such as the quarter-inch NPT, which is a national pipeline thread. So we decided to go with a Honeywell transducer. For breadboard and quick testing, DIP, which is a dual line packaging, would have been a much better chip to use. But for production, SMT, which is surface mounted technology, it is a better choice as it allows you to solder directly to the printed circuit board that you're going to be working with and using on any project. Transducer sizes and fitting combinations have been discontinued and are pretty hard to find. So it was much more beneficial to us to come with a smaller pressure transducer and use unorthodox standard sizing couplers to make it work.
Additionally, through the project, we also utilized an agile scrum process. This helped us really streamline a lot of the development process because this made it so that there was very little loss of communication between the parties that were involved. Also, this made it so that if the entire group was assigned a task, the entire group was notified of it. through the Scrum Master. Additionally, we also experienced scope creep throughout our project. Scope creep was essentially that we had to revise our product to incorporate additional capabilities that were not initially planned. That's where the IMU comes into play. Also, during our senior design project, we also started trying to future-proof our design. And by future-proofing, we were designing for the acceptance of multiple sensors. By doing this, this allowed us so that in case that the sensor that we were using was discontinued or no longer being supplied, we could switch out to a different supplier. And although the sensor that we're using is linear, in the future, if we wanted to switch to a non-linear sensor, we would also have this capability should a supplier stop supplying or a producer stop producing the sensor.
So our first choice for coding was Kotlin. So we started to learn the syntaxation and libraries for some time. We learned enough to just start the basics, but due to the time constraint that we had to choose the alternative, I guess, language that we were familiar with to make the coding and app development done before the due date for our senior project. That was the reason we had to switch to other language, which was the app inverter. So the whole implementation and developing of app, we just did it through the app inverter. And we had some issue on Bluetooth side. For some reason, our Bluetooth was set to the master, which was wrong. We had to switch it back to the slave since our phone has to be act as a master to pick up any client. We had to just switch it back to the slave mode. So we had a quick learning of how to just flash the Bluetooth using the Arduino, I guess. And then for soldering part, it might be easy for some people to just solder the wires two wires together, but in our case, since our transducer sensor was sensitive enough to that raising its temperature could burn the chip, so we had to do some practicing while we soldering the wires, not burn the chip. So we all wanted to just collaborate in this soldering part. So all we did is just practice for some time, and we all just contributed evenly on soldering part. And then for implementing the code, we had an argument that we needed to implement the analog to digital conversion for our input voltage, since our input voltage was receiving as an analog. I'm sorry, it was receiving from analog. That's why we had to just convert it back to digital. And then the second approach that we said it might be helpful, just sending a raw analog data through the Bluetooth to phone, and then from using the app, just converting that analog voltage to digital. We implemented both, but it turns out at the end that the second approach, which were just sending a raw data, was faster and less coding and more efficient. The whole process from getting the data and converting it back to digital and compiling it was in 2 cycles, which for testing result was fast and efficient, I guess, since we just picked the second approach. So in next slide, we will show a quick demo of how we design and implement the whole project.
For future developments, we wanted to add an additional channel or multiple channels for pressure readings based off of additional tire pressure sensors. That way we could get a individual pressure for each of the 4 tires. We also wanted to add an initial measurement unit as an additional sensor. And alongside with that, we wanted to add a memory card for data logging. This would give us a black box capability. Should the vehicle undergo a collision, we could record however many seconds before the collision. So that way we would have some sort of evidence that could be presented in court should the evidence be needed. Additionally, we wanted to implement algorithms for collision detection. So that way we could decide how much of the data log we wanted to save. And other than that, we also wanted to learn how to implement the design using radio frequency. So that way we would not be limited just to Bluetooth only.